Some more examples, I think, would make voltage a lot more clear, so let's do some practice with this idea. So what we have here is a system. Who cares how it got there? It is what it is. But these lines each are set at a certain voltage. So what's the voltage at point A? 30 volts. Point B? 30 volts. They're on the same line. If you remember from the Fallstad simulation from last week, this is actually called an equipotential. It's one of those things I had to turn off. It's a line that shows these voltages. You'll find in readings the word potential just by itself is used pretty much to mean the exact same thing as voltage. Why? That's annoying, I know. Sorry, it is what it is. So I figured we'd do some problems right now and go through this idea of what is voltage. So question for you. What point has the highest voltage? What point has the lowest voltage? Are there any ties? What point has the highest potential energy? What about lowest potential energy? Take a second, try and figure that out. What point is the highest voltage? Well, A and B, they're both at 30 volts. What point is the lowest voltage? Well, E and F, they're both at 10 volts. Which point has the highest potential energy? This is a goofy one because the question doesn't make sense. There's no voltage, there's no potential energies because voltage is energy per charge. If there's no charge, there's no energy. Voltage doesn't really matter. All right, that's one of the weird things about this. All right, let's try another one. A positive 2 coulomb charge moved from point A to point C. How does its energy change? Well, if we look at this idea that energy is charge times voltage, I can say, okay, at point A, it has 30 volts, and it's a 2 coulomb charge, so that's 60 joules. At point C, it's at 20 volts. It's a 2 coulomb charge. It has 40 joules. How much energy change? Negative 20 joules. Notice this is potential energy for a single charge. If I did a 3 coulomb charge, what would the answer be? Yeah. 30 times 30 is 90. 30 times 20 is 60. Be a delta U of negative 30 joules. Now what's interesting about that is we can also look at this idea that delta U is Q delta V. We had a change of negative 10, 3 times negative 10, negative 30. All right, same system. What if we moved a negative 3 coulomb charge from E to A? Did energy increase or decrease? because it's negative. It's actually a decrease in energy. We have delta U is equal to Q delta V. I have negative 3 coulombs times a change of 20 volts. Positive because I'm gaining as I move from E to A. I'm losing 60 joules of energy. This is starting to make sense. It's a little bit wordy. It takes some time. So ask some questions. I'm going to put some questions in another video. You guys give that a shot, and we'll call that a day.